Hi. So today in this video we will learn force and motion. Let's begin. The objectives of this video are the topics force, system and external world, agent, unbalanced forces, contact and field forces, free body diagram and rules to draw free body diagram. So the first topic is force. Force is very much familiar with us. Push or pull. When we push something, we apply force. When we pull something, we apply force. Now, force is a scalar or vector. That's right. Force is a vector because it has a direction. It has a certain direction. Now, what is the letter used for force? So the letter used for force is F, and the unit of force is Newton, after the great scientist Newton. Next is system and external world. So, what is a system? So, the object which we are considering, on which force is applied, that object is called system. In this example, you can see the force is being applied on this ball, and we are considering this ball. So, ball is the system. Other than the ball, everything is external world. For example, the hand is external world and this ball is system. In If we consider the hand can be a system because hand is having a force of this ball. Ball's weight is a force and that weight is on the hand. So the hand can be a system. So as I said, it depends on the interest, which one you are having interest, which one object you are considering. If I consider this ball, the ball will be a system. If I consider this hand or the palm, this will be the system. Now, everything around the system which may interact with the system is external world. So, for example, here the ball is being interacted with the hand. So, hand is the external world. The ball is being interacted with the air around it. The air is external world. So, everything around the system which may interact with the system is external world. Next, unbalanced forces. You can see in this picture the girl is down and the boy is up. It means the right now the girl has more weight or more force than the boy. This is an example of unbalanced forces. When the forces are not equal, in this case, the boy and the girl's weight are not equal, or the force by the girl and the force by the boy is not equal. So this is an example of unbalanced forces. What happens after unbalanced forces? We say this is non-zero force. The total force here in this system is non-zero force. Now, unbalanced forces change motion. It means it can speed up or it can lower down the speed, slow down the speed. Let's move to the next. Now, agent. What is the agent? Simply the one which is giving the force is agent, or we can say the cause of the force is agent. If you push a ball, your hand is a agent. If you are pulling a chair, Your hand is again the agent. So agent is something which is applying the force. Now here is a question, quick question. What is the agent in case of gravity force? So the answer is the mass of the earth. Mass of the earth is the cause of the gravity. So the mass of the earth is the agent. You know. Next is contact force. Very clear it is by the name contact. So the force which needs a contact, a touch by the agent and the system. For instance, if I want to pick a book, I need to touch the book. And then only I can lift the book. I can apply a force. So this case, the force is contact force. These are the examples of contact force: the normal force, frictional force, and elastic force. The other force which is opposite to the contact force is non-contact force, which is also known as field force. Field force. Field force needs only field, only space between. It doesn't need any touch. It doesn't need any contact. Example, the gravity force. You can see here. Earth pulls this apple towards towards itself. So that gravity force, no need any touch. This is an example of field force. We have other examples like magnetic force, also a field force, electric force. Now, there is something called free body diagram. Free body diagram is a picture, is a diagram of forces acting on a system. We will use free for body diagrams for different questions. Now, what are the rules how we can draw a free body diagram without any mistake? Here are the rules. Number one is, in your free body diagram, your system must be as dot. You have to make a dot to show the system. Example, if you are pushing a chair and you need to make the free body diagram of this pushing of chair, the chair must be a system and that is shown as a dot only. Now the next rule is, force all forces which are being applied in the system should be shown as arrow. You need to make arrow for the forces. Now the direction of the arrows are away from the system, must be away from the system. Irrespective of the forces you are pushing the chair or pulling the chair, the arrow must be away from the chair. Now the length of arrow must be proportional to the size of the forces. It means if there are two forces, one is 5 Newton and then the other is 10 Newton, there must be two arrows. One size will be, for example, 5 centimeter. Other arrow must be of 10 centimeter. Now the next rule is label the forces. You have to label the forces. Means which force is this? Is this gravity force? Is the drag? Is the magnetic force? Whatever, the friction force. And of course you use the letter F. Use the subscript, you know to mention the agent and the system of the force. It will clear, the who is applying the force, who is the agent. Here is an example of free body diagram. You can see this. This is actually a free body diagram, not this one. Because here you see the dot. This block is here a dot only. So this is a free body diagram. And you can see the three arrows, 1, 2, and 3. And these are the forces. And this is a labeling, F equal mg. This force is mg force, which is weight, gravity force. And this is, you know, the normal force. This is pull, another force. You can see that the length of this force is smaller than this one. It means this force is less than this force. So always make the lines or the size of the forces, size of the arrows proportional to the size of the forces. Thanks for watching.